This lesson is Chapter 6, Lesson 5, Percents of Increase and Decrease. The essential question for this lesson is, what is a percent of decrease and what is a percent of increase? We have a few vocabulary words that we need to make sure we know how to define as we go through. So that's percent of change, percent of increase, percent of decrease, and I'd like to add one more here. It would be percent of error. This is something that we're going to do in this lesson, so it should be a vocabulary term as well. So let's start with a percent change. A percent change is the percent that a quantity changes from the original amount. So just let's say, for example, that at the beginning of the day we had $10, and at the end of the day we had $15. And if we want to know what the percent of change is from $10 to $15, what we're actually thinking about is how much did it change from the beginning to the end, and that amount, what would it be as a percent of the original? So let's look at our example here. We started with $10 and we ended with $15. So how much did it change? Well, to find the change between any two numbers, we take the larger minus the smaller. So we have 15 minus 10 is equal to 5. So the amount that it changed was $5. But we're looking for the percent that it changed. So we want to know this $5, what percent of the original amount would that be worth? All right? And how do we figure out what 5 out of 10 is as a percent? $5 is the amount of change out of the original amount, out of $10. So it's 5 over 10, and we would turn that into a decimal, which would be 0.5, and then we would change that into a percent. Well, 0.5, we all know, is worth 50%. So when we went from $10 to $15, we increased by $5, but we could also say that we increased the amount of money we had by 50%. All right? So $5 is worth 50% of the original $10 that we had. And that's what we're talking about with percent change. All right. Oops. So let's move this down a little bit here. So our key idea, percents of increase and decrease. When the original amount increases, like the example we just had when we went from $10 to $15, it's a percent of increase. And there's a couple of little equations here that tell you what a percent of increase is and what a percent of decrease is. But we're going to use something a little bit different, but we could still go over these. A percent of increase is the new amount minus the original amount. And you'll notice that I did that over here, 15 minus 10, divided by the original amount. 15 minus 10 was equal to 5. That was right here. And then I divided by the original amount, which was right there, 5 over 10. And then we changed that into a decimal and then into a percent. So that's a percent increase when the value increases. When the original amount decreases, the percent change is called a percent of decrease. So let's say, for example, I started with $10, but by the end of the day, I only had $5. Okay? So the equation here for percent of decrease says take the original amount, which is $10, minus the new amount, which was $5, and divide it by the original amount, which is $10. Well, the change in the top is 10 minus 5. That's how much it changed. It went from 10 down to 5. So we subtract. 10 minus 5 is equal to 5. So it changed by $5. And if we divide that by the original amount, we get the same fraction, 5 over 10, which is equal to 0.5, which is equal to 50%. So again, the percent decrease is 50%. Percent decrease. The difference between the percent increase and percent decrease is just that one is going up and one is going down. So it went down by 50% this time. In our first example over here, it increased by 50%. I went from $10 to $15. So it went up by 50%. That was a percent increase. In the second example, it went down by $5, so it was a 50% decrease. All right, so a percent change. So what I'm going to do here is I'm going to erase this, and I'm going to give you one equation that I think works for everything. And it kind of incorporates both of these into one thing. So if we're looking for the percent change, okay, that's what we're doing here. The percent change. So I like to write it like this. Percent change is equal to the amount of change divided by the original. So all you got to do is figure out how much did it change and divide it by the original. And then you're going to tell me, is it an increase or is it a decrease? Did it go up or did it go down? Remember, you have to, when you solve this right here, it gives you a fraction. You have to then change that fraction to a decimal and then into a percent, because we're talking about a percent of change, okay? So you change it into, you write it as a fraction first, then as a decimal, and then into a percent. You can go right from a fraction to a percent if you know the percent right away, but a lot of times you have to change the fraction to a decimal first and then go ahead and change it into a percent. All right, so let's go through some examples. Finding a percent of increase. The table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? Okay, so I'm going to start with my formula. Percent change is equal to the amount of change divided by the original. So I look at my table here, and on Saturday, I was online for 2 hours. On Sunday, I was online for 4.5 hours. So to find the amount of change, I have to take the difference between those two numbers. And the difference between any two numbers is always the bigger minus the smaller. So 4.5 minus 2 is the amount of change divided by the original. Well, the original is which one came first. And in this case, Saturday comes before Sunday, so the original amount was 2 hours. All right? So in the top, I have 4.5 minus 2, and that is 2.5 over 2. And I'm going to go ahead and use a calculator and do 2.5 divided by 2. And I end up with 1.25. Okay, but this is the percent change written as a decimal. So I have to change this into a percent. And how do I do that? Remember, we move our decimal point 2 places to the right. So that means it's 125% change. And since it started at 2 and went to 4.5, I could say that it was an increase. Okay, so my percent change is either an increase or a decrease. And in this case, it's an increase because the amount went up. So that just means that this 2.5, that's the amount of change. If we compare the 2.5 to the original amount, 2.5 is 125% of the 2 that's in the bottom there, the original amount. Anytime you have something that's more than 100% of the original, that means it's bigger than the original. You should remember that from when we did other percent problems, all right? So here's a couple on your own questions that are about percent of change. Again, you're going to use this formula here to solve it. So go ahead and pause the video, do these 2 problems, and check your answers when you're done. Okay, so hopefully you've taken care of those problems. So let's go through them. Find the percent of change, round to the nearest 1/10 of a percent if necessary. So in number 1, let me extend the page here. In number 1, we went from 10 inches to 25 inches. So the percent change is equal to the amount of change divided by the original, and we're going to change it into a percent. Well, the amount of change, we're going from 10 to 25, so the difference between those two is a subtraction problem, 25 minus 10, divided by the original, and the original was at 10, so we'll put that in the bottom. 25 minus 10 in our numerator is 15, so the amount of change was 15. All right, it went from 10 to 25, it increased by 15. And we're going to divide that by the original amount, and when we do that, we end up with 1.5, but that's a decimal, so we have to change that to a percent. Move our decimal point 2 places, fill in a 0 there. So that is a 150% change, and since it went from 10 to 25, it's an increase. It went up, so it increased by 150% of the original amount. All right, so 15, the amount of change, 15 is 150% of the original amount of 10, okay? All right, we're going from 57 people to 65 people in number 2. So again, the amount of change is equal to, I'm sorry, not the amount of change, the percent of change. I want my percentage change equation. Percent change is equal to the amount of change divided by the original amount, and we'll turn that into a percent. All right. The amount of change went from 57 to 65, so we find the difference to find the amount of change, 65 minus 57. Divided by the original, it started at 57. And we go ahead and do that. 65 minus 57 is 12. 65 minus 57, I'm sorry, is only 8. All right, changed by 8. And the original amount is 57. So let's go ahead and do that in our calculator. 8 divided by 57 equals, and now we got a little bit of a decimal here, so we're going to round it at one point. So I'm going to do 0.140. And to change this to a percent, move my decimal place 2 points to the right, 2 decimal places to the right, and it looks like it would be 14.0, which will just be 14%. All right, we don't need the 0 there because it doesn't add any value to the number. So there you go. So these were both increases. All right, they both started at a number and went up. So those would be percent changes that are increases. All right, let's look at example number 2. Finding a percent of decrease. So it looks like we got percent changes that are going down. The bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013? Well, we have to get some information from the graph that we have here. So in 2012, which is right here, there were 28 home runs. All right, so 2012, there were 28 home runs. In 2013, which is right here, there were only 20 home runs. So there was a decrease in the amount of home runs. The percent change in home runs is equal to the amount of change divided by the original. And again, the amount of change is the difference between the two numbers. So we subtract them, bigger minus the smaller, 28 minus 20. Now, in 2012 is the original because this is the year that comes before. So that's the original amount. So we're going to divide by the original, which is 28. And we're going to go ahead and do the subtraction. 28 minus 20 in the numerator is an 8. 8 over 28 is our fraction that we now need to change into a decimal and then to a percent. So 8 divided by 28 in our calculator is a long decimal, so we're going to round that. So we're going to have 0.286. That's rounded. And then if I change this to a percent, move it 2 places to the right, and that would be 28.6%, and that's a decrease. So what this means is that these 8 home runs that it decreased, this 8 is 28.6% of the original amount. 8 is 28.6% of 28. So it went down by 28.6%. All right? All right. Now, a variation of percent change is something that we call percent error. I told you we'd be doing this at the beginning of the lesson. And what the percent error is, it's the percent that an estimated quantity differs from the actual amount. So somebody's going to make an estimation, an educated guess about something. And the percent error is giving us a percentage of how far away from the actual amount the estimation actually was. All right? So the way we find that is we find the amount of error. And again, the amount of error is very similar to the amount of change. All right? The amount error is going to be how much the difference between the estimate and the actual. So I kind of want to put that in here somewhere. The amount of error is equal to the difference between the estimate and the actual. All right, so you might want to put that in your notes. The amount of error is the difference between the estimate and the actual, and then we're going to divide that by the actual amount. All right, so let's take a look at an example here. So you estimate that the length of your classroom is 16 feet. So again, you looked at your classroom and you're taking an educated guess based on what you see. And you estimate, you didn't measure it, just with your brain, you estimate that it's 16 feet. All right, somebody measures it and the actual length is 21 feet. Find the percent error. So the percent error will be equal to the amount of error divided by the actual. Well, the amount of error we said is the difference between the estimate and the actual, and the difference is always the bigger minus the smaller. So the difference would be 21 minus 16. And then we're going to divide by the actual amount. All right, it's not the one that's first, it's the actual amount, always with percent error. So that's 21 feet. Well, the difference between 21 and 16, 21 minus 16 is 5, and our actual is 21. So what we're really trying to figure out here, this difference right here, this 5, what percent of the actual is that? And that's what the percent error is. So I'm going to go ahead and I'm going to divide that. 5 divided by 21 equals, and that's 0. We'll round it, 238. And we have to change that into a percent since it's asking for the percent error. So we'll move it over 2 places, and that's equal to 23.8%. So that means my estimate was off by 23.8%, or your estimate. Whoever made this estimate was off by 23.8%. Okay? This 5 was worth 23.8% of 21. That's how much we were off by. Okay, if you have any questions on that, please make sure you ask in class. So there's a couple of on your own questions here. You can go ahead, pause the video, take care of these questions, and then check them when you're done. Okay, so hopefully you've taken care of those. So if we take a look here, the first one refers to example 2. What was the percent of change from 2010 to 2011? So we're going to go up to example 2 and take a look at the bar graph. So what was the percent change from 2010 to 2011? In 2010, there were 18 home runs. In 2011, there were 10 home runs. So I'm going to go ahead and record that information down. So in 2010, I'm going to double check that. It was 18 home runs. And in 2011, there were 10 home runs. But let me double check that just to be sure. 10 home runs. Okay. So what we want to do is find the percent change. So the percent change is equal to the amount of change, not the percent of change. That's what we're looking for. Is equal to the amount of change divided by the original. Okay, you got to make sure you use the right formula. It's not percent error for this question. So it's the amount of change divided by the original, the one that came first. Well, the amount of change is the difference between the two numbers, so it's 18 minus 10. And the original amount, 2010 happened first, so 18 home runs is the original. And we go ahead and calculate this. 18 minus 10 is 8. So again, we're trying to figure out how much is 8? What percent of 18 is that 8 worth? Okay, that's the amount of change. So 8 divided by 18 equals, and that's equal to 0.444 if we round it. And if we change that to a percent, that would be equal to 44.4%. And since it went down from 18 to 10, that would be a decrease. Okay, so that takes care of number 3 right there. Number 4, we have in example 3, your friend estimates that the length of the classroom is 23 feet. Who has the greater percent error? And then explain that. Okay, so remember that in example 3, that the actual length is 21 feet and your friend's estimate was 23 feet. So the percent error was equal to the amount of error divided by the actual amount. Okay, remember you get your formulas correct here. The amount of error is the difference between the estimate and the actual, and that means the bigger minus the smaller. The estimate was 23, the actual was 21, so it's 23 minus 21. Over the actual, which is 21, divided by the actual. We go ahead and do the math. 23 minus 21 is 2, and that's out of 21. So we're going to take that 2 over 21 and go ahead and divide that to turn it into a decimal. And that is equal to 0.095 if we round it. And if we convert that into a percent, we then move 2 decimal places to the right, and we end up with 9.5%. And the question is, who has the greater percent error? And that would be in the first problem that we did where you did the estimate. So because 23.8% is bigger than 9.5%, you had a bigger percent error, which just means that your friend did a better estimate. Their estimate was closer to the actual than yours was, which makes sense. Theirs was only 2 away from the actual, and up here, yours was 5 away from the actual. So they did a better job, which means they had less error, so a smaller percent of error. So that was it for today's lesson. So what we have here is the highlighted problems that we would like you to do for homework. Make sure you bring those in, show them to your teacher. Ask any questions for the things that you didn't understand. We'll be more than happy to help you with those.